Namaste students. Today we'll start our new chapter, that is electrochemistry. Now before the starting of the chapter, first of all we have to know about the meaning of the term, that is electrochemistry. So first of all we'll learn about the meaning of electrochemistry. Now, what is electrochemistry? Electrochemistry is the branch of chemistry which deals with the relationship between the electrical energy and the chemical changes taking place in a redox reaction. So, electrochemistry is a branch of chemistry which deals with the relationship between electrical energy and chemical changes taking place in a redox reaction. It means that how chemical energy can be converted into electrical energy, or how electrical energy can be used to bring about chemical changes in those redox reactions which are otherwise non-spontaneous. We know that redox reactions are of two types: spontaneous redox reactions and non-spontaneous redox reaction. In our 10th class, we have studied about the reactivity series of metal. In reactivity series of metal, we have studied that some metals are more reactive than the other metals. Like if I take the example of potassium and copper. Now I know that potassium is more reactive than copper, and in 10th class we also studied about the displacement reaction, in which we studied that a more reactive metal displaces a less reactive metal from its solution. It means if we have potassium and CuSO4, and because potassium is more reactive than copper, so potassium displaces copper from its solution and form K2SO4 plus C. Now this reaction is spontaneous reaction. This reaction is spontaneous reaction because this reaction occurs by its own. So what are spontaneous reaction? Those reactions which occur by its own are known as spontaneous reaction. But suppose if I want Cu to displace K2 from K2SO4. If I want Cu to displace potassium for K2SO4, so this is not possible because copper is less reactive than potassium. So less reactive metal is not able to displace a more reactive metal from its solution. So this reaction is not possible. But if I supply an external source of energy to this reaction, if I supply an external source of energy to this reaction, then this reaction also proceed and get converted into CuSO4 plus K. Now this reaction is known as non-spontaneous reaction because this reaction takes place only in the presence of an external source of energy. As soon as I remove this external source of energy, it gets stopped. But this reaction is spontaneous reaction because it occurs by its own. Similarly, redox reactions are also of two types. One is spontaneous reaction and another one is non-spontaneous reaction. In spontaneous reaction, chemical changes taking place by their own. And in those reactions, we convert the chemical energy into the electrical energy. But in non-spontaneous reaction, we use electrical energy to bring about the chemical changes in those reactions. So basically, electrochemistry is a branch of chemistry which deals with the relationship between the chemical energy and the electrical energy. That is how the chemical energy get converted into the electrical energy in a spontaneous reaction, and how electrical energy can be used to bring about the chemical changes which taking place in those reactions which are otherwise non-spontaneous. And the cells and the apparatus which is used to convert or to proceed these conversion, the apparatus which is designed for these conversions, means conversion of chemical energy to electrical energy or electrical energy to chemical energy. In electrochemistry, we have some apparatus for this conversions. The apparatus which are used for these conversions, those apparatus are known as electrochemical cells. Those apparatus are known as electrochemical cells. So what are electrochemical cells? Electrochemical cells are the apparatus, are the device which are used to convert either electrical energy into chemical energy or chemical energy into electrical energy. Now, if we talk about in brief, we have number of electrochemical cells, but basically electrochemical cells are divided into two categories. Means we have principally two different types of electrochemical cell. And what are the name of those two electrochemical cells? Those two electrochemical cells are electrolytic cell, and second one is galvanic or voltaic cells. So basically we have two different types of electrochemical cell, one electrolytic cells and another one galvanic or voltaic cells. Now in electrolytic cell, so in electrolytic cell, we are dealing with the non-spontaneous reaction. Means in electrolytic cells, with the help of the electricity, we will bring about the chemical changes in those reactions which are otherwise non-spontaneous. Means electrolytic cell is deal with this kind of relationship. This is a non-spontaneous reaction. Without the external source of energy, this reaction is not possible. So in electrolytic cell, we are dealing with this kind of reactions. But in galvanic cell, what we are dealing with the spontaneous reaction. Means in galvanic cell, the chemical energy get converted into the electrical energy. So galvanic cells are dealing with the spontaneous reaction. So in both are electrochemical cells, means both are designed to convert one form of energy into another form of energy, either chemical to electrical or electrical to chemical. But in electrolytic cell, the electrical energy get converted into the chemical energy. Means electrical energy is used to bring about the chemical changes in the reactions which are non-spontaneous. And in galvanic or voltaic cell, the chemical energy which is produced in the redox reaction get converted into the electrical energy. Now we study electrolytic cell in detail. Later we will study the galvanic cell, but today in this video we will study the detailed portion of the electrolytic cell. Now, before the starting of the electrolytic cell, we have to know about a term that is known as electrolysis. Before the starting of the electrolytic cell, we have to know about a term which is known as electrolysis. Electrolysis. Now, what is electrolysis? If I split this term into two, first is electro, which stand for electricity. And second one, lysis, which means breakdown. Or decomposition. So what do you mean by electrolysis? Electrolysis is the decomposition or the breakdown of the electrolyte by the passage of electricity through its aqueous solution or its molten state. So what is electrolysis? Electrolysis is the process of the decomposition of the electrolyte by the passage of electricity either through its aqueous solution or its molten state. It means there is a condition that electrolyte should be present either in the form of its aqueous solution or in the form of its molten state. Means this process is not possible if we take the electrolyte in the solid form. So electrolysis is the decomposition or the breaking of ions of the decomposition or breaking of electrolytes by the help of the electricity when passing through its aqueous solution or its molten state. Now, for performing this electrolysis, we have a kind of apparatus. In that apparatus, we have an electrolytic tank, a vessel, in which we have electrolytic solution. Now, this electrolytic solution either present in the form of its molten state or in aqueous form. Two metal rods are dipped in this vessel. Now, these metal rods are externally connected with a source of electricity like battery. So, basically, for performing electrolysis, we have a vessel in which the vessel is filled with the electrolytic solution either in the aqueous form or in molten state. Two metal rods are dipped in the electrolytic solution and these metal rods are externally connected with a source of electricity like battery. Now what happened in your book, it is written that if the terminal is positive, consider it as anode, and if the terminal is negative, means if the electrode carry positive charge, it is anode, and if it is negative, then it is cathode. But I give you a trick here that whether you are dealing with the electrolytic cell or you are dealing with the galvanic cell, which we studied later on, in both the cells, if you are talking about the electrodes, the electrode where the oxidation occur, that electrode is always anode irrespective of the charge, whether it carry positive charge or it carry negative charge. But if there is an oxidation process in that particular electrode, that electrode is considered as anode, and if there is a reduction at that particular electrode, that electrode is considered as cathode. So if anode means oxidation is there, and cathode means reduction. So here you can remind this, or you can recall it as anox catrate. So anox means oxidation. If there is an oxidation, the electrode is considered as anode, and if there is reduction, the electrode is considered as cathode irrespective of the sign, whether it carry positive charge or it carry negative charge. If oxidation is there, surely it is anode, and if reduction is there, surely it is cathode. So this is the apparatus which we use for electrolysis. Now we'll study the phenomena or the complete process of electrolysis. Now the electrolysis process can be easily explained on the basis of ionization theory. So the phenomena of electrolysis can be easily explained on the basis of ionization theory. Now, according to ionization theory, whenever we take aqueous solution or molten form of an electrolyte, its ions get dissociated. Means suppose if I am talking about KCl solution. So whenever KCl is present in solid form, its ions are closely packed to each other. Whenever the KCl is present in its solid form, its ions are closely packed to each other. But whenever I convert the solid form into the aqueous form or in molten state, then its ions get dissociated and move apart from each other. So whenever the electrolyte is present in its aqueous form or in molten state, its ions get dissociated. So here the ions are dissociated, means ions are present in the dissociated form. Now, because of this electricity, this terminal carry positive charge and this terminal carry negative charge. So, in this solution, we have two different type of ion, K positive and Cl negative. We have two different type of ion, K positive and Cl negative. So, K positive will move towards the negative electrode and Cl negative will move towards the positive electrode, because we know that the unlike charges attract each other. So K positive will be attracted by the negative terminal electrode and Cl negative will be attracted by the positive terminal electrode. As soon as K positive reaches to this electrode, as soon as the K positive reaches to this electrode, what K positive did? K positive attract one electron from the negative terminal electrode and get converted into K. So K positive gain one electron from this electrode and get converted into the neutral species. Now we know that acceptance of electron means reduction. Here acceptance of electron is taking place. So acceptance of electrons means reduction, and if there is a reduction, then the terminal or the electrode should be cathode. According to this cat, right? So if there is a reduction, then the terminal or the electrode should be cathode. So this electrode becomes cathode. I'm not dealing with the negative sign. Clear? Here the reduction occurs. That's why I'm saying that this electrode is cathode. Now what happened here? Cl negative reaches to this terminal which carry positive charge. What Cl negative did here? Cl negative loses its one electron and gets converted into Cl. Cl negative loses its one electron and get converted into Cl, and losing of an electron is known as oxidation. Losing of an electron is known as oxidation, and if there is an oxidation, it is considered as a anode. So reduction, cathode, oxidation, so it becomes anode. So whenever we are dealing with either electrolytic cell or galvanic cell, the electrode where the oxidation occurs, considered it as anode, and where the reduction occurs, considered it as cathode. I hope this point is clear to you. Now, here what happened? Whenever the charged species reaches to the electrode, what happened? It loses its charge. It loses its charge and get converted into neutral species. Whether I am talking about cation or I am talking about anion, as soon as it reaches to its respective electrode, it releases its charge and get converted into neutral species. So the process of conversion of an ionic species into neutral one, the process is known as primary change. What it is? Primary change. So what is primary change? Primary change is the conversion of the ionic species into the neutral one. So there it is, primary change, because in this the K positive get converted into K. K positive is a charged one, whereas K is the neutral one. So K positive get converted into K. That's why it is termed as primary change. Here also Cl negative get converted into Cl. That's why it is also termed as primary change. But if I'm talking about K, in 11th class we studied about S block. That if we talk about alkali or alkaline earth metal, if I talk about alkali metal, the potassium is alkali metal because it belongs to first group. So first group remain present in its atomic form. Means they are stable in their atomic form, in their monoatomic form. But if I'm talking about the halogens, they are stable in their diatomic form. They are stable in their diatomic form. It means if I have fluorine, chlorine, bromine, iodine, they are more stable in F2, Cl2, Br2 and I2 form as compared to FCl, Br and I form. So Cl is more stable when it is present in its Cl2 form. So as soon as the second Cl will form in the solution, 2 Cl combines to form 1 Cl2 molecule. Clear? Potassium is stable in its monoatomic form, so it remains as such. Means when as soon as K positive reaches to its respective electrode, it gains its one electron and get converted into K, which is stable one. So at anode, at cathode, I got potassium. Clear? At cathode, I got potassium. But at anode, I didn't get Cl. I got Cl2. Why? Because Cl is not stable in its monoatomic form. Cl is stable in its diatomic form. So whenever the primary product undergo any other change to convert itself into a more stable product, then it is termed as secondary change. Then it is termed as secondary change. It is termed as secondary change. So in this electrolytic cell, we get two changes. One is the primary change and another one is the secondary change. What is primary change? Primary change is the conversion of the charged species to the neutral one. But what is secondary change? Secondary change, if the product which we get from the primary change is not stable and it get converted itself into any other product, then this conversion is known as secondary chain. So at cathode, I get the primary product, but at anode, I get the secondary product because primary product itself is not stable and it undergoes conversion by itself and get converted into the secondary product. So this is the phenomenon of the electrolysis. Now again, here is one major problem that from the starting, we are studying that in electrolysis, the electrolyte should be present in its aqueous form or in molten state. Now, if the electrolyte is present in its molten form, then okay, no problem. We get the same product which we have in the electrolyte, like KCl. Clear? But suppose if it is present in its aqueous form, then we have to study something extra for the for determination of the products which we get at anode or cathode. Why? Suppose I have aqueous KCl solution. Now aqueous KCl solution means KCl plus water. Though the dissociation constant of water is very high, but still we get some amount of H positive and OH negative ion in the solution. Means along with K positive and Cl negative ion, we have H positive and OH negative ion also in the solution. And if we have H positive and OH negative ion in the solution, then we have two cations at cathode and two anions at anode. But out of these two cations and these two anions, only one cation and one anion get discharged at cathode and anode. Now, which anion get discharged at cathode or which anion get discharged at anode, it depends upon two factors. Clear or not? If we are dealing with the electrolysis of molten electrolyte, then okay, no problem. We get those products which are there in the electrolyte. Means if the electrolyte is KCl, we get K or Cl. If the electrolyte is CuSO4, we get Cu or SO4. If the electrolyte is NaCl, we get Na and Cl. But if we are taking the aqueous solution of these electrolytes, then it's not necessary that we get the products which are present in the electrolyte. Why? Because along with the ions of the electrolytes, we also have the ions of H positive and OH negative. Means we have two cations at cathode and two anions at anode. Out of these two cations and these two anions, only one is capable to discharge at cathode and anode. Now, which anion will discharge at anode or which cation will discharge at cathode? It depends upon two factors. Now, what are those two factors? Those two factors are, first one is discharge potential. First one is discharge potential. Now, what is discharge potential? Discharge potential is the ability of an ion to discharge, ability of an ion to remove its charge. That is discharge potential. So, first one, discharge potential. Now, discharge potential is ability to discharge, ability of an ion to remove its charge. So, it means lower the discharge potential. If the discharge potential is low, means higher the discharge potential. Higher the discharge potential, it means there is less tendency to remove the charge. Lower the discharge potential, it means there is more tendency of the ion to remove the charge. So, lower the discharge potential, greater is the ability of the ion to remove its charge. So, if we have K positive and H positive at cathode, then if suppose the discharge potential of H positive is less than that of K positive, then we get the product from H positive, not from K positive. And if the discharge potential of K positive is less than that of H positive, then we get the product from K positive instead of H positive. So, first factor is discharge potential. Lower the discharge potential, greater is the ability of the ion to release its charge. And second one is the nature of electrode. Second one is the nature of electrode. Means these two electrodes, what are the nature of these two electrodes, from which metal these two electrodes are made. This also affect the product of electrolysis or electrolyte when it is present in its aqueous solution. These two factors are applicable only when the electrolyte is present in its aqueous solution. Now we'll take some example. From those examples, your concept becomes clear that how discharge potential and how nature of electrode will affect the formation of product at cathode and anode. First of all, I'll take the example of electrolysis of molten PbR2, means lead bromide. First of all, I take the electrolysis of molten PbR2, that is lead bromide. So, PbR2, as soon as I form the molten solution of PbR2, it undergoes dissociation to form Pb2 positive and 2Br negative. Now, this Pb2 positive will move towards cathode and Br negative will move towards anode. So, at cathode, what I get? Cathode, Pb2 positive gain 2 electron, get converted into Pb. Now, lead is stable in its monoatomic form. So, Pb is the final product which I get at cathode. It means at cathode, I get the product as a result of the primary change. Clear? What is primary change? Primary change is the conversion of the charged species into the neutral one. So at cathode, I get the product from the primary change because the product from the primary change is stable. Now, if I talk about anode, at anode, I get Br negative. Now, what Br negative did? Br negative releases one electron and get converted into Br. But this is halogen, and halogen is not stable in its monatomic form. So 2Br reacts to form Br2. So at anode, the final product which we get is as a result of the secondary change. So the final product which I get, that is PBr2 on electrolysis. I get PB at cathode and Br2 at anode. PB at cathode and Br2 at anode. So this is my final reaction. Means the overall reaction which I get, PBr2 upon electrolysis gives Bb plus Br2, but the overall reaction is this. Means the stepwise reaction is this and the overall reaction is this. Now this is simple. Why it is simple? Because here I am taking the molten PBr2. I am not taking here the aqueous PBr2. I am taking here the molten PBr2. That's why it is. Now we will study that how discharge potential play an important role in determining the product which we get at cathode and anode. Suppose we are doing the electrolysis of aqueous NaCl. Now aqueous NaCl means we have NaCl and water in that particular electrolytic tank. So we have NaCl and water. NaCl and water upon electrolysis gives Na positive, Cl negative, H positive and OH negative. Out of these four ions, Na positive and H positive move towards cathode, whereas Cl negative and OH negative will move towards anode. So at cathode, we get two ions, that is Na positive and H positive. At cathode, we have Na positive and H positive. Whereas similarly at anode, we have Cl negative and OH negative. Now we studied that lower the discharge potential, greater is the ability of that particular ion to remove its charge. Now out of Na positive and H positive, the discharge potential of H positive is less than the discharge potential of Na positive. Discharge potential of Na positive means as soon as Na positive and H positive reaches their respective electrode, that is cathode, H positive loses its ion, H positive loses its charge and get converted into neutral species because its discharge potential is less than that of Na positive, whereas Na positive remain present in the solution. So the reaction which we get at cathode is H positive plus electron gives H, but H is not stable in its monatomic form. So as soon as H form, it gets converted into H2. So we get H2 at cathode, that is the secondary product, the product which is formed as a result of the secondary chain. Though the electrolyte is NaCl, but we didn't get any at cathode. We get H2 at cathode because of the discharge potential of hydrogen. Discharge potential of hydrogen is less than that of sodium. That's why it remove its charge it remove its charge faster than that of Na positive. That's why we get H2. Now, if I talk about anode, so At anode, we get Cl negative and OH negative, and the discharge potential of Cl negative is less than that of discharge potential of OH negative. The discharge potential of Cl negative is less than that of OH negative. So, who discharged first? Cl negative. Cl negative remove one electron and get converted into Cl. But because Cl is not stable in its monatomic form, so it get converted into Cl2, means the product which we get here also, that is due to the result of the secondary change. So if I write the overall reaction of the electrolysis of aqueous NaCl, it is NaCl aqueous form upon electrolysis. Upon electrolysis, I get H2 at cathode plus Cl2 at anode and plus Na positive and OH negative in the solution. So this is the overall reaction of the electrolysis of aqueous NaCl. If I have molten NaCl, then the product is Na and Cl2, means at cathode I get Na and at anode I get Cl2. But because it is not molten NaCl, it is aqueous NaCl. That's why I get H2 at cathode and Cl2 at anode. So I hope first point is clear to you, that is how discharge potential affect the product which we get at anode and cathode. Now we'll move to our second factor, that is the nature of the electrode. That is how the electrode, that is how the nature of the electrode will affect the product which we get at anode or which we get at cathode. Now suppose we are doing the electrolysis of aqueous CuSO4 by using platinum electrode. Means the cathode and anode are made up of platinum. There is a tank. In tank we have aqueous CuSO4 solution, means CuSO4 along with water, and we are using platinum electrode. So what happened? In that particular electrolytic tank, we have Cu2 positive ion, SO4 2 negative ion, H positive ion and OH negative ion. Why these four ions are there? I hope this point is clear to you, because we have CuSO4 plus water. Now, Cu2 positive and H positive will move towards cathode. SO4 2 negative and OH negative will move towards anode. So, at cathode, we have two ions, Cu2 positive and H positive. Now, which will discharge first? The ion whose discharge potential is less than that of the other ion. Now, the discharge potential of Cu2 positive is less than that of H positive. So, Cu2 positive will discharge first. So, Cu2 positive gain 2 electron and get converted into Cu. Now, Cu is stable in its monatomic form. So, the Cu remain as such. It don't want to convert into more stable form, and we get the product as a result of the primary change. Now, at anode, if I talk about at anode I have two ions, SO4 2 negative and OH negative. Now, which will discharge first? The anion whose discharge potential is less than that of the other ion. Now, the discharge potential of OH negative is less than that of SO4 2 negative. So, OH negative will discharge. In NaCl we studied that Cl negative will discharge, because the discharge potential of Cl negative will less than that of OH negative. Here the discharge potential of OH negative is less than that of SO4 2 negative. So OH negative release one electron to get converted into OH. but OH is not at all stable. So 4OH combines to form 2H2O plus O2. Means at cathode I get copper and at anode I get oxygen. From OH negative I always get oxygen in the electrolysis. So I get the product as a result of the secondary change, not as a result of the primary change. And in the solution I have here H positive and here SO4 2 negative. So the overall reaction becomes CuSO4 aqueous. Upon electrolysis, it gives Cu at cathode plus O2 at anode and plus H positive and SO4 2 negative in the solution. H positive and SO4 2 negative ions in the solution. Now, I think there is a question in your mind that discharge potential is there, the role of discharge potential is there, but what is the role of the electrode here? Now, the role of electrode will clear to you when I take another example. So, we'll study another example, then the role of electrode is clear to you. Now, suppose I'm doing the electrolysis of aqueous CuSO4, but this time I'm not taking the platinum electrode, this time I'm taking the copper electrode. Means the electrode of the same metal whose solution is present in the electrolytic tank. Clear? I am doing the electrolysis of CuSO4, aqueous CuSO4, but this time I am taking the copper electrode in place of the platinum electrode. Now study what happened when we change the electrode from platinum to copper. Now this time I am using copper electrode. So because it is aqueous CuSO4, so again we have 4 types of ions in the solution: Cu2 positive, SO4 2 negative, H positive and OH negative. Now Cu2 positive and H positive will move towards cathode, SO4 2 negative and OH negative will move towards anode. Again the same process. At cathode we have Cu2 positive and H positive. Now we know that the discharge potential of Cu2 positive is less than that of H positive. So Cu2 positive gain 2 electron and get converted into Cu, and I get the result on the basis of the primary change, product on the basis of the primary change. But now the role of the electrode. At anode, I have SO4 2 negative and OH negative. Now, because the electrolytic solution is of copper and the electrode is also made up of copper, so as soon as at cathode Cu get deposited, means the concentration of Cu2 positive ions in the solution decreases. Now suppose in an electrolytic tank, this is electrolytic tank, and this electrolytic tank I have 1 molar of CuSO4. It means 1 molar Cu2 positive ion and 1 molar SO4 2 negative ion. 1 molar Cu2 positive ion and 1 molar SO4 2 negative ion. Now Cu2 positive ion when moved towards cathode, it converted into Cu, as a result of which the concentration of Cu2 positive ion in the solution decreases. So what happened? At anode, neither SO4 2 negative nor H positive are capable to remove their charge. Why? Because anode itself undergoes oxidation and loses electron and get converted into Cu2 positive to neutralize the solution. Clear? Because the electrode is made up of copper, this electrode is made up of copper, So it undergoes self-oxidation process. It undergoes self-oxidation process. This copper releases electron and get converted into Cu2 positive. This Cu2 positive come into the solution, as a result of which the solution becomes neutral. It means its concentration remains same as the previous one. So as soon as the Cu2 positive at cathode get converted into Cu, the same amount of copper from the anode electrode get converted into Cu2 positive. So at anode, the reaction which I get is Cu get converted into Cu2 positive plus 2 electron. It means at anode, neither I get SO42 negative, nor I get the neutral species from OH negative. Instead of the neutral species, I get a Cu2 positive species which is present in the solution. And why this is so? Because of the presence of the copper electrode. So, in this way, the nature of the electrode affects the type of the product which we get at the anode and at the cathode. If it is platinum electrode, what I get? I get O2, because the discharge potential of OH negative is less than that of SO42 negative. But right now this is copper electrode, so I get here Cu2 positive. So if we have aqueous electrolyte, then the two factors which determine the product at cathode and anode are: first one, discharge potential. Lower the discharge potential, greater is its ability to lose its charge. And second one is the nature of electrode. From the last two examples, I hope it is clear to you that is how the nature of electrode will affect the product of electrolysis. So students, that's all for today. We'll do the quantitative basis of the electrolysis, the quantitative aspect of the electrolysis in our next video. Till then, do more and more examples of the electrolysis of different electrolytes.